All right, let's get started. Once again, welcome to the Be Audacious AI and Machine Learning webinar series, session 3. I'm Newton Miner, one of the co-founders of Be Audacious, and I'll be your host for this exciting session. We are really honored to have all of you here as we explore the fundamentals of AI, Python, and machine learning tools in an engaging and interactive way. For those joining us for the first time, this webinar is part of our ongoing efforts to empower tech talent and foster a learning culture around AI, machine learning, and other emerging technologies. So this is only but our first series of the mini series that we're going to have. Before we dive into today's session, I'd like to introduce my incredible co-founders who are a part of this journey in shaping Be Audacious. That is Ivy and Abigail. Please take a moment to introduce yourselves. We can start with Ivy, then Abigail, who will also take a moment to tell us what Be Audacious is all about and why we do what we do. Ivy, the floor is yours.
Oh, okay. So sorry, I was muted. Hi guys, my name is Ivy Macharya, and I am part of two communities currently here, Be Audacious and Kickstart. So at Be Audacious, we are an online tech community, and we are aimed at creating a safe and inclusive space for current and aspiring techies or tech professionals. So we provide a platform to explore various tech tracks. And as you can see right now, we're in the AI ML phase or series. And we also connect people through webinars. We're going to be having workshops, community sessions, physical events, and we aim to bridge the gap between learning and real world application. So we are here to make sure that when you're starting your tech journey, you don't feel um, you don't feel down or you do not feel overwhelmed. It is easy, and you just have to be bold and believe in yourself. We always um, encourage people to be confident, especially when you're starting in your tech journey. It might feel overwhelming at first, but trust me, it is easy and it's doable. There are so many people doing it. So welcome to Be Audacious, and the links are on the chat. So we have a WhatsApp group link, we have a channel where we share opportunities, internships, jobs, events, and even memes sometimes to lighten up the mood. And we also have our LinkedIn channel. And for amazing partners, we do have Kickstart. Their company LinkedIn is also there. So thank you for the opportunity.
Hi guys, I hope I'm audible. My name is Abigail Ndegwa, also a co-founder at Be Audacious. We are excited to have you for this session. And in the spirit of fostering and empowering you guys to overcome imposter syndrome, we will also be having in-house sessions. So yeah, be on the lookout for that too. And have a nice session. Thank you. Back to you, Newton.
Oh, thank you for that. Today, we're also joined by our friends from Geeksters who are collaborating with us for this event. Geeksters is a dynamic tech community just like us that supports developers and tech enthusiasts in their growth. And I'd love to invite one of the representatives to briefly introduce Kickstars and what they do. Welcome.
For the warm welcome and introduction. My name is Monica Wamuhu. I am one of 3 co-founders of Kickstars. Actually, one of us is here with us and is from speaking. Her name is Ivy. And the other one who has not been able to join us today, her name is Jane Wanjiro. We are a community for women in STEM. So if you're a woman and you want a community that you can relate with, we also have our own thing that we are doing. We have actually a webinar tomorrow at 7:30 p.m. to 8:30 p.m. with a software engineer, Philomena Ngao. She's from Safaricom. And we're going to be talking about the power of mentorship and networking. If you're lucky enough, she could end up being your mentor. So please join the session if you can tomorrow. Yeah, so technically that's what we do. Our LinkedIn channel has been shared on the chat section, but more about us will be talked about during our webinar tomorrow. Thank you so much, Be Audacious, for partnering with us on this series, and I can't wait for more that you guys have planned. Thank you. Move to you, Newton.
Thank you so much for that. Now on to the main highlight of today's session. I'm not sure if Alvin is around. Alvin, if you're around, you can just say hi.
Hi, I'm here.
Okay, thank you. To guide us through this exciting journey, we are honored to have an exceptional speaker with us, Alvin Kamau. So Alvin is an AI engineer and the founder of Augmenting AI. He has a vast experience in building AI-powered solutions and mentoring developers in this field. Today, he'll be taking us through an interactive session on AI, Python, and ML tools. Without further ado, Alvin, the floor is yours.
Thank you, Newton, for such a wonderful introduction. Just to dispel the notion that I am an AI god, I am not. I'm just a student at KCA. I am the AI lead at KCA, and yeah, I'm the one who started the AI and machine learning chapter at the KCAU Tech Club. So this is just a passion that I have myself, and I have mostly taught myself. And so I just want you guys to see it as being possible and not some far-fetched thing that only people from the West do. So today I'm going to take us through a hands-on experience. So I encourage you to look for the nearest laptop. It doesn't need to have anything installed. Just look for the nearest laptop so that you can follow along as I'm going to take us through this session. I hope by the end of the session you will have gained actual experience in building machine learning models. So we're going to build one, and it's a simple one, so don't get afraid, do not fear. So yeah, so I'd like us to start. Let me share. Yeah, so today I'm going to take us through a hands-on experience using in building AI. We're going to learn a bit of Python, and we're also going to see a few machine learning tools and their uses, so that once you're done with this session, you can be able to look at the different tools and take it up on yourself to use them and to build different things using them. So yeah, my name is Alvin Kamau, and yeah, that is a short introduction about myself. So today we are going to learn why we use Python for machine learning and AI. And the reason why we use Python is not necessarily because Python is the best language. Of course, there are people who choose to say that, but the actual reason why is Python is easy to read, and it is simple enough for anyone to understand. That is why it was chosen. And the other reason is because during the time of machine learning boom, or when machine learning was starting rapidly, the major players in this field, like Google, like Facebook, like Tesla, they chose to use Python because most of their engineers in their teams were already using Python. So most of the technologies and the tools that we are going to use have already been built by um, uh, these major players. So some like TensorFlow and PyTorch have been built by Google and Facebook respectively. So Python was chosen because it was, at that time, it was a mature and stable language. So that's why Python was used essentially. But as time has progressed, other languages have come up, like JavaScript. So there's a there's a separate library for TensorFlow called TensorFlow.js, and it is particularly for JavaScript. Because now JavaScript is a mature language, it is also able to perform some of the tasks that Python can do. So yeah, so I'm going to take us through a crash course of some sort. I know we have in this group, we're going to have people who are new to programming and to tech, but we're also going to have advanced people. So for those who are advanced, let's give these other people a chance to learn how Python works. And then as we move on to more advanced things, by the time you're getting to build a model, they're going to know at least what is happening. So that's my humble request from all of us. So let me also turn on my video. I hope we can all see my sharing. So yeah. So I'll start here. The website that I'm using is called Google Colab, and Google Colab implements something that is called a Jupyter Notebook. So a Jupyter Notebook is just a simple notebook like any other notebook you can have, like any physical notebook. Like for example, I have a physical notebook over here, and it has text. Just the way this notebook has some text is the same way a Jupyter Notebook works. But in addition to just having text, it has things called cells. And these cells give you the ability to write and execute code such that you do not have to move out of the notebook and go and set up your environment and install different packages and then now start writing your code. It is a good place for writing code together with text, especially when you want to teach someone something, or if you want to walk through different steps of going through like building a model. So Jupyter Notebooks are great. But now Jupyter Notebooks are, you need to install them yourself. So you need to install it on your local machine and set it up yourself. And now Google made it possible for us to just go to this website, collab.research.google.com, and you can now write your code and your text here online. So your laptop doesn't need to have major specs, or doesn't have to be to have Python installed. It doesn't have to have anything. So this is one of the tools that is used in machine learning and AI. It is called a Colab, or a notebook, depending on where it is run. If it is run locally, you call it a normal notebook. But if you want to say specifically the one that Google has built, it is called Google Colab. So this is the first tool we are going to learn about. So if you're following along, kindly just go to collab.research.google.com and then start a new notebook. So yeah, that's what you should do. I'll go slowly so that by the time you're catching up with us, I won't have gone too far. So we'll start with print statements. This crash course is not necessarily for you to learn the ins and outs of Python, but for you to be able to understand the syntax such that you are able to read more complex code and you can understand what is happening, so that I don't leave people behind when we go to writing a bit more complex code. Not entirely complex, but just has more stuff to it. So we'll start with a print. And okay. So we'll start with a print. And a print gives us the ability to output code to the console or to the terminal. So for example, I want to say hello Be Audacious community. I just write print and I put that text inside quotation marks and I run this cell. Once I run this cell, I get this as the output. 1 second, let me close some sessions. Okay, at least I've run the cells, so we'll just go through until it decides to connect. So if you have too many sessions running, so for example, I was building a different model. Now I've had to terminate that session so that we can run this cell. So let's just follow along. So if you want to print something to the terminal, you write print and then you put the text inside quotation marks, and then once you run the cell, you will be able to see the text that you put inside the quotation marks. So this is how you print things in Python. Just print brackets that. Next is called variables and data types. So variables are, for example, you want to store a certain value and you want to use it later on in your code, or for example, that value will change. So for example, you want to have the name of the current user in session. So you will define the variable like this. You'll give the variable name equals and then the value of that variable. So for example, here my variable name is ironically name, and then equals Alvin, my name. And the data type of this variable is a string. String are defined when you put anything inside quotation marks. So for example, if you put, you do number equals this, and then you do 12, this is also a string. It won't be defined as an integer, which is the next thing you're going to see, but this is going to be a string because it is inside quotation marks. So the next one is age. You write the variable name that you want, and then you give it the value. So my current age is 23, and that is an integer. But now when you have numbers that have decimal places like this one, my height is 5'9", that's called a float. So if it is 5'9.2345, it is still a float. So a float are numbers that have decimal places. And finally, we have a data type called booleans. Booleans are either true or false. So true or false. So for example, we can have is morning, and currently it's not morning where I am, so this will be false, like that. So if we are to print these values, remember how we print? We write the print statement and then brackets, and then now we just refer to the variables themselves. So there's name, is age, is height, is student, and we can clearly see here what is printed out. So that's how you define a variable and the different data types. Okay. And then now we want to take in a user input. So for example, you want to ask the user how old they are. So you write the input statement, and then you put brackets, and then you ask whatever you want to ask. Like for example, how old are you? And then since we want to use that value that the user will input, we save that value in a variable, something we've just learned over here. If you want to save any value in so that you can use it later on in your code, you save that value in a variable and you give that variable a name. So for example here, I've given the name new age. So then I'll print you are the new age, whatever value I'll put here, years old. So in this case, it asked me how old are you? I said 27, and the output was you are 27 years old. So we've seen how to deal with the variables by giving variables names. We've seen how to print and you've seen how to take user input. So there's that. We've also seen data types. Then there's basic arithmetic. This is just plus, minus, division, multiplication, and different kinds of division. And if you want to get the what is it called? The remainder or the root the truncated value. So those are different kinds. So we'll see here we have two variables here, x and y. They have different values. So x is equals to 10, y is equals to 3. So we print out the value of this addition. So x plus y, we expect it to be 10 plus 3, which is 13. And we can clearly see here is 13. Subtraction, x minus y, 10 minus 3 is 7. Same thing here. Multiplication, 10 times 3 is 30. Division is x and then / y. And that is 10 divided by 3, which is 3.333 until it reaches it is up to infinity, really. So Python, so that it saves on or instead of writing all the 3's until infinity, it rounds off to 5 so that the calculation terminates. So this is not that my computer is wrong. It's just something that Python does. So there's that. And then there's floor division. This is where you want the specific integer. You do not want the remainder or the decimal places. You just want the integer. You do not want the floating point number. So you do double / like that. So 10 / 3 gives you 3. Because if 3 times 3 is 9, you get 1 as the remainder. So 3 is the floor division or the integer division. Then there's modulus, x, percentage sign 3. This gives you the remainder. So like 3 times 3 is 9, so 10 minus 1, 10 minus 9 is 1. So modulus gives you the remainder. And then exponentiation, this is where you raise a number to a certain number. So for example, this is 10 raised to 3. So that's 1,000. So that's basic arithmetic. These are the signs that are used in arithmetics in Python. Then once you've gotten used to Python a bit, you now deal with conditional statements such as if else. So this is if this condition is true, perform this task. Else, if that is not true, then perform this other task. That is exactly what we are seeing here. So we've defined a variable called age here, and we've given it the value of 18. And then we've said if this age is greater than or equal to 18, you print you can vote. But, or else, if that is not true, if this number is not meeting this condition, if this age is not meeting this condition, then you print you cannot vote yet. So that's how a print statement is. It's pretty easy to read. So it's if age, you give it a condition, and then you do colon what you want to be done. So here you can do age plus 20, and then you can vote. Then you print the new age. You do age, so you do age will be equals to age plus 20, and then you print the new age. So here you can do whatever computation you want to do, whatever calculation you want to do, you can do it right here. And then you output something, or you whatever. So if this condition is met, this code inside here is executed, else this is what will be executed. Then now we move on to loops. Loops, this is where you want to execute some code or to run some code so long as a certain condition is met. So long as a certain condition is met, you perform a certain code. So this is a loop that continuously run until a certain condition stops being true or is not met. So the two loops that we will look at is a for loop and a while loop. So a for loop says this. So for every, so just walk with me here. For every integer or for every item within the range 5. So this range 5 will generate numbers from 0 up to the number that you give it here. So for every item in range 5 or for every integer in range 5, print that item. So what this does is it runs the first time, and then range 5 is executed, and it generates numbers from 0 up to the 5th index. So something that I didn't look at is Python is 0 indexed, meaning you start from 0. So for example, you are trying to count the number of words in my name here. Like for example, you want to count the number of words in this word iteration. So we'll start with 0, 1, 2, 3, 4, 5, 6, like that. So I will be the 0th index. It will be index 0. And then T will be index 1. Then E will be index 2. So that's what, when I say Python is 0 indexed. So when range 5 runs, it will start from 0. So it will start 0, and then it will do 1, 2, 3, 4. And 4 will be the 5th index. So the value that you put in here is the number of indices that you want to print out. So now we can clearly see here, after we've printed each iteration, we can clearly see here that we are outputting iteration 0, iteration 1, and when you count these, there are 5 iterations, just like we defined here in our range 5. So this is what our for loop looks like, and that's what it does. So for every index in range 5, print that index, and that's what it does. And then while you start by defining a variable that, like for example, here we are defining a variable called count, and we are giving it the value 0 to start with. And then we say, while count is less than 3, so clearly as when we start, count is clearly less than 3 because 0 is less than 3. So it will print count is 0 because when we start, count is 0. Then we add this count plus equals 1 is the same as doing new count will equal previous count plus 1. So instead of doing this, let me write here, count equals to count plus 1. So instead of writing this is a short form. It does the same thing as doing this. So I hope that makes sense. So this now increments the value of count to now plus 1. So whatever it was before to plus 1. Here the value of count was 0. The first time we ran this while loop, the value was 0. So it will be 0 plus 1, and then now the new count will be 1. So it will run again because 1 is still less than 3. It will do that until it comes here and sees that while 3, count now will be 3, is less than 3, then it will exit the while loop. It won't continue because 3 is clearly not less than 3. That's why it does count up to number 2. Okay, I hope that makes sense. Let me try and manage this session. Let's do that. Let's move this video. Okay, I hope now that will work. So now we're going to look at lists. For those who are coming from JavaScript, lists are the same as arrays. So they're just an ordered list of things, which is called an array, or now in Python it is simply called a list. So now we have fruits, and fruits is how you define a list in Python is you give it a variable name, and then you create the list by doing box brackets like this. So this is an empty list, but then you want to add things. So for example, you want to add different cars. So BMW, that's one car. You want to add another car. You want to add another, like that. So these are this is a list of cars. So you've given it a variable name, and then you've opened box brackets, and then each value like that. So like here, we're going to see a list of fruits: apple, banana, cherry. And if you want to access a specific item in the list, you do fruits, the variable name, and then you choose the index. Remember, Python is zero index. So whatever is at index 0 will be apple. And we can clearly see here, apple is the first one that is printed when we say, here, apple is the one that is printed when you do print fruits at index 0, it prints apple. And then if you want to add something, you do fruits dot append mango. That adds here at the end. Here it adds mango like that. So you don't need to create now a new list. You just do append mango and it adds to it. So when you print the total fruits, it will have mango in it. And then now we have 3 more remaining. Functions, we are going to see how functions work. This is when you have a certain piece of code that you are repeating so many times, or that performs a specific task. So these are called functions. Like for example, if your application is going to greet someone once they log in into the application, you create a function. So def is simple, is short form of define. So it is to define a function. So you do def, and then you give the function a name. So you give it greet, and then you give it what are they called? Um, Someone remind me. Arguments. You pass in arguments here like name. This is something that it's going to use inside the code. So now it's taking someone's name, and then it returns hello plus that name. So I've given it my name, Alvin, and then so it will return, the print statement should say hello, Alvin. If we want it to say something else like um, George, so we give it the name, we run it, and it will say hello, George. I hope that makes sense. Then, so this is how you define a function. Def, function name, an argument. It can have multiple arguments, just so that it can have multiple arguments, and you can use all the arguments inside your code. So I hope that is clear. And then dictionaries, for those who are coming from JavaScript, or I don't know what other languages uses this, but they are called objects. Objects are just key value pairs. So just the way in a dictionary you can find keys and values, and the keys are the words you're looking for. So for example, you can go to the dictionary and look for the word joy. So the word joy, you will find it under J, and then you go to J-O, and then J-O-Y. And then that the word joy will be the key. The value is the definition of joy. So dictionaries are just key value pairs. Same to Python, same to what is in an actual dictionary. So this is what a dictionary looks like in Python. A name and a value, a key and a value. Key, value. Age is a key, value is 23. Location is a key, value is Katodo. So yeah. Then now if you want to print the values that are in the dictionary, you do person, box, brackets, and then you give it the key name in JavaScript so that people can reference or know what it does. It could be person dot name. This is the equivalent of this. So person dot name is person name. So I hope that makes sense. Similarly to person age, this is for getting the age value. Finally, we are going to import a module. So Python is not uh, um, Python has certain libraries built into it. So, for example, we have the math library built into it. So we can also import that from the Python library. But there are other libraries that we do not have built into Python, and some of them we're going to see, like the ones you're going to use during machine learning. So you need to install them and import them. So you import external pieces of code that help you perform certain tasks. So here we're going to see this math library gives us the ability to do square roots, gives us the ability for pi and doing powers. It gives us the ability to do other functions, but these are simply the easy ones so that you, for example, purposes. So like instead of doing or remembering that pi is 3.14159, you just do math.pi and it gives you this value. I hope that makes sense. So now we're going to move on uh, to now building a machine learning model. I am going to try to explain as much as possible so that I don't leave people behind. But do not try to understand the nitty gritties of things. Try to understand the high level thing, like how we are going about things. Like when we are loading and preparing the data set, look at what we are doing, why we are doing something. The code shouldn't chase you away. It is not that hard. Since we've already gone through how Python works, we'll be able to understand what is happening there. So we're going to get started. The setup that we need to do is we need to install something called TensorFlow. But before we even get here, let me talk about um, a few other tools that are used in Python, in machine learning. The first one is called NumPy. NumPy gives us the ability to perform computations using multidimensional arrays. So multidimensional arrays are things that we learned in high school, things like matrices, things like vectors. These are multidimensional arrays. So you can have vectors that are 3 by 3 vectors, 2 by 2 matrices. You can have 10 by 10 matrices. You can have 28 by 28 and even larger ones. So NumPy gives us the ability to perform these computations efficiently. The next one is called pandas. Gives us the ability to perform to visualize our structured data. Like for example, you can have a CSV file, um, that has data like this. Let me show us. So we can see this is how a CSV file looks like. It has a patient ID, it has a state name, age, gender, diabetes. It looks similarly to what an Excel document would look like, but they're not entirely the same. The file format is different. So CSV means comma separated values. So this is how it looks like. So I hope that is clear to everyone. So The next one is matplotlib. This one enables us to plot different values. Like, for example, if you want to plot bar graphs, if you want to plot just a line, use matplotlib. The next one is called scikit-learn. Scikit-learn gives you the ability to write machine learning algorithms that do predictions. Like, if you want to write a machine learning algorithm to classify certain data, or you want to build a regression model where you can predict if a certain um, data will look a certain way, so that's regression. Then there's clustering. If you want to cluster different groups of data that have similar features, scikit-learn is the one that will give you the ability to write those models. And then finally, there are these two called PyTorch and TensorFlow. PyTorch is built by Facebook. TensorFlow is built by Google. They are pretty much exactly the same. It's just that PyTorch is more geared towards actual machine learning engineers and data scientists. TensorFlow is much more beginner friendly, so that's what we are going to use today. Yes, also Seaborn. Seaborn can be used together with matplotlib for machine learning and for plotting and visualizing things. So yeah, that's great. Yeah, so we're going to start by installing TensorFlow. Let me go back to the code. Yeah, so yeah, yeah. So we're going to install TensorFlow. The way you install packages in Python is you do pip install TensorFlow. Pip is Python's package manager. If you're coming from other languages, different languages have their own package managers, like npm for Node and JavaScript. So for Python is pip install TensorFlow. It installs and then you can use it. So let's run that cell. And let's hide that. Okay, good. Then now we can now import the TensorFlow package, and we will do TensorFlow import as TF so that we don't have to write TensorFlow everywhere. It is just shorthand. So TensorFlow, I import TensorFlow as TF, then we can print the version. So here we are using version 2.18. So if you're following along, these are the steps that you would go ahead to do. So I'll also post this Python notebook somewhere so that you can refer to it later on. I'll probably post it in the group. So yeah, there's that. So now we need to load and to prepare the data set so that we can build the model. We're going to use a data set called MNIST, MNIST. MNIST stands for Modified National Institute of Standards and Technology. And they have a database or data set that has handwritten digits from number 0 to number 9. So this is this is the hello world of machine learning. If you want to get started with machine learning, this is what you will use to test things out and to to start building models. So we're going to do MNIST is equals to TF. Remember, we are referring to TensorFlow as TF. So tf.keras, this is another library within TensorFlow. Do not worry too much about it. It's just a library within TensorFlow. So tf.keras.datasets, and then we are getting the MNIST dataset. We are storing that into a variable called MNIST. Then we are getting the data from the MNIST dataset. This is what this piece of code does. It loads the data. And inside the data, we have two different sets of data. So we have the training set, which is used to train the model, to help the model learn. And then we have the test data set, which is going to be used to test and to see how accurate our model is at generating predictions. Okay, I hope that's clear. Then now I would like us to display an image. So one of the libraries that we looked at was matplotlib, or one of the tools we looked at was matplotlib. So we're going to import matplotlib .pyplot as PLT so that we don't have to type all this. That's what this does. Then we will get the first image inside the training set, and we'll get the first corresponding label within that training set. Same thing with the test set. Here, this is the test, this is the training set. And then finally, we will run this so that we see the image. This image doesn't look quite clear because this image is actually a 28 by 28 pixel image. So the images that you take on your phone are probably 20 megapixels, 50 megapixels. For those of us who have high-end phones, Lambda 100 megapixels. But yeah, this is a 28 by 28 pixel image. That's why it looks very rugged. So this is the image. And the reason why we're doing this is images that are this small enable the model to learn faster so that we're not processing many pixels at the same time. We're going to look at that shortly. So here, xtrain.shape, this just tells us how many images we have in our training data set. So we have 60,000 images, which are 28 by 28 images. So yeah. So let me go a bit fast so that I don't take much of your time. So yeah, here we're going to now build the machine learning model. And from TensorFlow.keras.models, we're going to import a sequential model. A sequential model looks like this. This is how a sequential model looks like. Let me show you. This is how a sequential model looks like. It has an input layer. Then there's the first hidden layer. We call them hidden layers. There's a second hidden layer. And finally, there's an output layer. So in this model that we are building, this is a very simple model. So it's going to use a sequential model. And the reason why it's called sequential is because it processes data sequentially. So the data enters the model inside the input layer, and it moves in this direction. So data doesn't flow backwards, it moves in this direction. So this is also called a feed-forward neural network. The data is moving forwards in one direction. So it's also called a sequential model. Then we are going to import different layers. So there are different types of layers that are used in machine learning. There's a dense layer, there's a flattened layer, and there's a dropout layer. I'll go through while explaining what they are. So we've defined a model here, and it's the sequential model, just like we've looked at. This is the sequential model. This is how it should look in your head. This is how it should look in your head. So the first layer is called a flattened layer. So what a flattened layer does is it takes a 28 by 28 pixel image, this one that we looked at here, and then it flattens it out into a one-dimensional array. So you see this is a two-dimensional array. It has length, upper chin, length. It also has width here. So these are two dimensions. But for the flattened layer, it will take the two-dimensional array, which is a 28 by 28 pixel image, and then it will compress it such that it is one long array or list of elements. Just like you can see here in the comments that I have written, it will be something like 0.00, 0.00, 0.001, like that, up to the 784th element. And why is it the 784th element? It is because we are taking all the pixels in this image, which is 28 times 28, because it's a 28 by 28 pixel image, and we get 784. So that's what a flattened layer does. So this flattened layer is our input layer here. So these neurons, this gray part that you see here, in our model, you should imagine it as having 784 input layers. 784 might look like a large number, but it is actually not. In bigger models, such as the ones that are used for ChatGPT and the like, they have millions of input layers, input neurons. So 784 is quite small. So yeah, so that's the input layer. The next one is called a dense layer. A dense layer is called dense because it is fully connected to each neuron in the previous layer. So each neuron in the dense layer is receiving input from 784 inputs. So this single neuron here is receiving from 784 of the input layer. That's why it's called dense, because it's receiving input from every of the input layers. So I hope that makes sense. It's called dense. And we've chosen 128 because it is a standard in machine learning that this number works best. You can take this code and play around with these numbers. So long as if you put these numbers, you ensure that you're not over consuming your resources over here, because we have been given 12 GB of RAM for free. Remember, this is for free. So 12 GB of RAM and 107 GB of disk space. So if you're going to play around with this code, just remember you have limited resources. Okay, so 128 is just a good number. Activation, this is an activation function. I'll explain this a bit. I don't want to take much of your time, but let me just explain this so that you go knowing learning something. So an activation function, look at it like this. When you are driving a car and you come to a stop at a red light, at a stop, traffic light stop, when you look at the lights and you see red, that immediately tells you in your head that you need to come to a stop. When you see orange, it tells you that you need to prepare to start moving. And then green tells you to go, to start moving and move out of here. So what this activation function does is that's the same thing that happens now in a neural network. When it is learning data, certain information is not relevant for the model to learn. So this activation function only fires up certain neurons. You see these gray parts, these are called neurons. So it only fires up certain neurons, or certain neurons are the only ones that are going to feed information or to feed data to the next layer. So this activation function limits the number of neurons that are going to release the information or to release the output. Once it has done the computation, only certain limit of certain neurons are going to release information. So, for example, only neurons that deliver a number that is 0.5 and above. I've seen Newton. So only neurons that are 0.5 and above are going to release information. So this is what an activation function does. You can play around with different activation functions and study more later, but yeah, that's what that does. Then now we have a dropout layer. This dropout layer drops certain neurons. In addition to certain neurons not being able to transmit information, certain neurons are completely switched off so that the model doesn't cram information or memorize information. It should be able to predict information, not memorize information. So that's what a dropout layer does, and it drops 20% of the neurons. And then finally, we have a dense layer for the output. So these are 10, because we have 10 numbers, 0 to 9. So our final layer has 10 values. That's it. So once we run this is going to define the model. Then now we need to compile the model. Compiling the model is giving the model certain resources that it is going to use to make itself better. So we're going to get a certain loss function that is called sparse categorical cross entropy. So this loss function is used in classification models to enable the model to see how wrong it is or how much error it has in its calculation. So when we compile this model.compile, we first of all pass into it an optimizer. So an optimizer just gives the model the ability to edit the weights. So what makes the model learn is the fact that it is able to edit weights within this neural network. So this Adam optimizer just tells the model that you need to increase the value of this weight, reduce some of this and that. The loss function, this is the one that tells it, this is what the actual value was, but this is what you predicted. So you are actually wrong by this amount. And then it enables the model to learn. And finally, we are going to output the metrics called accuracy. So that's it. So we're going to run this here. Let me invalid syntax. Oh, here. Epochs 5. So what this does, this is model.fit. This is to train the model. Fit is to train the model. And then you pass into it the X train, which are the images, and the Y train, which are the corresponding values. Like, for example, if you pass in an image for number 5, you also need to pass in the value, the label for number 5, so that the model trains on that image and then it is told that this is the actual value, but you predicted this value. What was the error? And then it calculates. And then epochs, these are the number of training runs or training times, so that it how many times it learns over the same training data. So we will run this and then we will see. So the first epoch is running, and we're going to see that the accuracy here is going to keep climbing. So it has ended the first training run at 70%. Then it's going to do the second training run. It will end at 82%. Then it's going to do the third training run. It will end at whatever percent. So yeah, at this point, if there's any question, I can take any question as the model is learning. Anyone who hasn't understood anything or any questions? Okay. So finally, we have ended with a model that is at 89% accuracy. This isn't a very good model. If you want a better model, you should probably aim at having 95 and above. So if this doesn't work, you can run this again, or you can increase the training times. So you can do 10 here, so that it trains for longer and gets higher training accuracy and lower losses. So we want lower losses and higher accuracy. But for now, we will work with that. And then finally, you can evaluate your model. So what evaluation does is it gives it new data that it hasn't seen, new images it hasn't seen before. So remember up here, we separated our data into training set and test set. So here we have used the training to train, and we've used the test to test. So you can after we've run, you can clearly see that the model is at 93% accuracy on new data that it hasn't seen before. So if this was perfect, it should be at around 98, 99%, because it's a simple data set, it's not large, and um, uh, it is a pretty simple machine learning model. So it should have gotten higher. But if this doesn't happen, you train again, and then you see how much you get. So that has been today's session. I'm sorry I've had to rush through this. I would have wanted to spend more time here, but I hope
Excuse me, Alvin.
to learn something. Yeah, sure.
A quick question.
Yeah.
Can a model be overwhelmed by data?
Can a model be overwhelmed by data? I don't think so. I think models are shaped by the data. So, for example, you have a certain data set and you want to train a model. Remember, a model is just an architecture. So, the architecture that you use isn't going to be overwhelmed by data. It is primarily going to give you outputs that have been determined by your data set. So if your data is extremely large and you use a model architecture that doesn't take into consideration the size of the model, size of the data, then you're probably going to get low quality output. So I don't think the model will be overwhelmed. It's just that it won't perform as expected. So you should take into consideration the kind of data and the size of the data that you're using to train a model.
Okay, thank you.
Yeah. Yeah, Emilio, you have a question?
So for me, my question was: does this, does this, is it a must for one to use the 75-15% when it comes to testing and training a model, like 75% of the data and training, or how do you know that? Okay, in simple terms, does this ratio 75-15 make the model so much efficient, or you can use maybe 90-10 for it to be more? Or is one able to determine by using this sort of ratio will make my model efficient and so on?
Yeah. So what I can advise you is I think you should try it yourself. The reason why we've come to 80-20 or 75-15 is because people have built models and they've seen that 75-15 or 80-20 is what works. But you should try it. You should try and put 90-20, 90-10 and see what will happen. But something that I can tell you, if you put a large training set as compared to the test set, you will get something called overfitting. And overfitting is where the model is cramming information from the data and not necessarily learning how to predict or learning features from the data and then being able to predict new data and being able to infer correctly. So if you do 90-10, you will end up with a model that is very good at predicting data it has seen before, but terrible at predicting data it hasn't seen before because it hasn't learned features in the data. It has just learned how to cram and to memorize the data it was trained on. So that's something I can tell you.
Okay, thank you for that. Then I had another question which I posted on the chat. So maybe you can tackle it after everyone has asked his or her question, and then
Okay.
I'll be glad.
Yeah, I've seen there are a few questions. Justin Jack, how do I learn Python for AI/ML? What you should do, first of all, learn the basics of Python. What I walked us through isn't entirely the basics. Those are just the high level things. You should go ahead and learn things like sets. You should learn things like classes in Python. These are things that you're going to use in more advanced machine learning concepts. And first of all, look to learn how Python is as a language. Once you've learned that, you can now move on to now using these libraries and tools and frameworks to build machine learning using these frameworks. So the first thing is you should focus on is learn Python the language. So you learn Python, you build a few projects or programs, and then you see how it works, and then now we move on to the next step, which is AI/ML. AI/ML uh, is quite complex in terms of it requires a lot of mathematics and such, but these packages and these libraries and frameworks like TensorFlow offer us a platform where we do not need to know the mathematics. We just need to know what frameworks or what model architectures we need to use or what functions we need to use. So that's what the good thing about this framework. Another question, any structured course can you recommend for a beginner in Python? For a beginner in Python, personally, I learn Python from their documentation. So I don't know, people learn differently. I personally learn better through reading. So if you're like me, you just go to Python, you search Python, and then you do Python for beginners or documentation, and then you read through the docs and you learn via that. If not, you can go to YouTube, and I'm sure there are very many good Python courses. But what I should encourage you, also W3 School, that's great. I used to use that uh, when I was learning the web, but it's also quite good. So what I will encourage you is to focus on learning specific things at one time. So don't cram too much at one time. Don't try and learn TensorFlow while you don't know Python yet. You will end up not being able to differentiate what is actual TensorFlow code and what is Python and what am I not understanding. Yeah, Wisdom, you can ask your question.
Mine is a quick one. When do you use SVMs and random forest?
Those ones are for those are decision trees, and they are used. So there are two things. There's traditional machine learning, and there's deep learning. So traditional machine learning is where you are trying to predict using simple machine learning algorithms like now SVM, support vector machines, and random forests, and uh, uh, such. But now, what I have shown us today is a section of AI called deep learning, where you use neural networks. So these are two different aspects where you use machine learning algorithms like SVMs and random forests. But this other area is where you use neural networks. So you should be able to differentiate those two. And I hope during these sessions, we'll be able to learn more about that. We'll be able to look at machine learning algorithms themselves, and also um, more to do with neural networks, which is the fancier side of things, but also the machine learning algorithms themselves for classification, for clustering, for regression, and such. They're quite fun and easy to implement. So yeah, I hope we'll be able to go through that when you're going through this AI ML track. So yeah, uh, I see there are quite a few questions. I won't be able to go through all of them. Let me go through one last one and then we can stop. There's a question that Emilio asked here. He said, for me, I'm having a question. I tried to run my class app in my computer and it won't connect with respective port. Maybe the lead can tackle it again in the session for more explanation. I ran it the first time before adding some features, before adding. Okay, I don't think this would be fair to everyone if we looked at it right now. What you can do is you can post it you can post the error in particular. You can have a screenshot, you post it qua group, and then whether it's me or someone else who is able to, they can be able to help you out. So because this isn't necessarily for what we are looking at today, I won't go into it. Yeah, Chukwomeka, you can say something.
Okay, sorry, I didn't hear me the first time I spoke. I want to ask, is there a community? Do you have a community, like maybe in terms of WhatsApp, Telegram, or so? Because I'm just coming now. I know I've missed a lot.
Okay, yeah. I think personally, I'll end my session there. I'll give it back to Newton. Newton will address the aspect of the community, and yeah, that's it for me. I hope you've been able to learn something, and I hope I didn't bore you too much. So Yeah, thank you so much for this opportunity. Good night.
Just wow, what an insightful session from Alvin. Thank you so much. At this point, you had planned for an interactive quiz to reinforce what you've learned, but unfortunately, we were unable to set it up in time. We sincerely apologize for that. But don't worry, we'll make sure to include fun, engaging activities in our future webinars to keep the learning experience interactive. You can just feel free to share your key takeaways or aha moments from today's session. And that being said, as we wrap up, I want to extend a huge thank you to our amazing speaker, Alvin Kamau, for sharing his knowledge and expertise with us today. We truly appreciate the time and effort you've taken to break down AI and ML in such a practical way, and we look forward to having you for another extensive session. Thank you so much. I also want to extend our gratitude to our collaborators, that is Kickstart community, for being part of this event. And of course, a massive thank you to each and every one of you for attending and engaging with us. Your enthusiasm and curiosity is what makes these sessions impactful. So before we wrap up, to answer your question, to stay connected with us, you can find us at the shared links in the chats. That is LinkedIn, Be Audacious Tech Community. The WhatsApp link is also there. And we also have not stated that we have an inclusion of our website. Well, it's still in development, but it's up. That is for those who are asking for notes on today's, let's say if you want a recording for today, the website is beaudacious.africa. Am I audible to everyone?
Yeah, you are.
Okay, thank you. So I'll proceed. We also have our website, that is beaudacious.africa. So this website is our platform where you can access upcoming events and past event content, such as this meeting for today, and even discover webinars from other tech communities, such as tomorrow's meeting for Geekstars in our events page. Be sure to check it out and stay updated on what's happening in the AI and machine learning space. You can just search Be Audacious Tech Community and head over to events. Today's meeting will be available from tomorrow. Once again, thank you all for being here. Keep learning, keep building, and most importantly, stay audacious. See you in our next session. You are free to leave at your own will. Thank you.
Dance within a view, golden streams flowing strong and true.